Question 1. Operational review demonstrates that a critical software update is nearing its deployment deadline. The development team has completed unit testing for all new modules, and the integration team is ready to begin testing the interactions between these modules and existing system components. However, to meet the aggressive deadline, the development lead proposes skipping the formal integration testing phase and proceeding directly to system testing, arguing that unit test coverage is high and any integration issues will be caught during system testing. As the Certified Manager of Software Quality, CMSQ, which approach best ensures the integrity of the software and adherence to quality standards? Option A. Accept the development lead's proposal to skip formal integration testing and proceed directly to system testing, relying on the high unit test coverage to identify any integration defects. Option B. Defer integration testing until after the initial deployment of the software update, addressing any issues found in subsequent patches. Option C. Conduct a limited ad hoc integration testing effort, focusing only on the most critical interfaces, and then proceed to system testing. Option D. Proceed with integration testing as planned, focusing on verifying the interfaces and data flow between all newly integrated modules and existing system components before moving to system testing. Correct answer is D. Proceed with integration testing as planned, focusing on verifying the interfaces and data flow between all newly integrated modules and existing system components before moving to system testing. Explanation. This scenario is professionally challenging because it requires a software quality manager to balance the immediate need for integration testing with the potential for downstream impacts on regulatory compliance and product integrity. The pressure to deliver quickly can lead to shortcuts that compromise the thoroughness of integration testing, potentially introducing defects that could have significant consequences in a regulated environment. Careful judgment is required to ensure that testing practices align with established quality standards and regulatory expectations, without unduly delaying critical releases. The correct approach involves systematically verifying the interfaces and interactions between integrated software modules, ensuring they function as a cohesive unit. This aligns with the principles of robust software development and quality assurance, which are implicitly or explicitly mandated by regulatory frameworks governing software used in critical systems. By focusing on the end-to-end flow and data exchange between modules, this approach directly addresses the potential for emergent defects that arise solely from the combination of components. This proactive identification and mitigation of integration issues are essential for maintaining product quality and meeting the implicit requirement of delivering reliable software, which is a cornerstone of regulatory compliance in many industries. An incorrect approach that prioritizes only unit testing before integration testing fails to address the core purpose of integration testing. Unit tests verify individual components in isolation, but they cannot detect issues arising from the interaction between these components, such as data format mismatches, incorrect API calls, or unexpected side effects. This oversight can lead to the release of software with critical integration defects that may not be discovered until later stages, potentially impacting regulatory adherence and user safety. Another incorrect approach that skips integration testing entirely to expedite deployment is professionally unacceptable. This directly violates the principles of sound software quality management. Integration testing is a critical phase for ensuring that the system as a whole functions correctly. Bypassing this phase significantly increases the risk of releasing a product with undiscovered defects, which can lead to system failures, data corruption, and non-compliance with industry-specific regulations that often mandate rigorous testing to ensure product reliability and safety. The professional reasoning process for such situations should involve a risk-based assessment. The software quality manager must evaluate the potential impact of integration defects on the system's functionality, safety, and regulatory compliance. This assessment should inform the testing strategy, ensuring that integration testing is performed at an appropriate level of rigor. Communication with stakeholders regarding the risks associated with any proposed deviations from standard testing procedures is also crucial. Ultimately, the decision must prioritize the delivery of a high-quality, reliable, and compliant product over short-term expediency. Question 2. Performance analysis shows a significant degradation in the response time of a critical customer-facing application. As the certified manager of software quality, you need to implement corrective actions and ensure adherence to standards. Which of the following approaches best addresses this situation? Option A. Immediately deploy a patch that temporarily reduces the load on the affected components, without a full investigation into the root cause, to restore acceptable response times as quickly as possible. Option B. Convene an urgent meeting to assign blame for the performance issue to the development team responsible for the recent code deployment and instruct them to fix it immediately. Option C. Initiate a thorough root cause analysis to identify the underlying reasons for the performance degradation, develop targeted corrective actions based on the findings, and implement these actions through the established change management process, followed by rigorous testing and monitoring. Option D. Implement a series of ad hoc configuration changes to various system parameters, hoping to stumble upon a solution, and document these changes retrospectively. The correct answer is C. Initiate a thorough root cause analysis to identify the underlying reasons for the performance degradation, develop targeted corrective actions based on the findings, and implement these actions through the established change management process, followed by rigorous testing and monitoring. Explanation. This scenario is professionally challenging because it requires balancing the immediate need for corrective action with the long-term implications of stakeholder trust and regulatory compliance. The CMSQ certification implies adherence to specific quality management principles and potentially regulatory frameworks relevant to software development and deployment. The challenge lies in identifying the root cause of the performance degradation and implementing effective corrective actions without causing undue disruption or compromising the integrity of the software or the development process. The correct approach involves a systematic, data-driven investigation to identify the root cause of the performance degradation, and then implementing targeted corrective actions. This aligns with the principles of continuous improvement and robust quality management systems, which are fundamental to software quality assurance. Specifically, it emphasizes understanding the why behind the issue before jumping to solution, thereby preventing superficial fixes that might not address the underlying problem. This methodical approach is crucial for ensuring adherence to established quality standards and regulatory requirements that mandate effective problem resolution and risk mitigation. An incorrect approach that focuses solely on immediate symptom suppression without root cause analysis fails to address the fundamental issues. This can lead to recurring problems, increased technical debt, and potential noncompliance with quality standards that require demonstrable root cause identification and resolution. Another incorrect approach, which involves bypassing established change control procedures to implement a quick fix, poses significant risks. This can lead to unintended consequences, introduce new defects, and violate regulatory mandates that require documented and approved changes to software systems, especially in regulated industries. Furthermore, an approach that involves blaming individuals or teams without a thorough investigation undermines team morale and the collaborative spirit essential for effective quality management. This can also lead to a culture of fear, hindering open communication about quality issues and preventing the identification of systemic problems. Professionals should employ a decision-making framework that prioritizes a structured problem-solving methodology. This involves 1. Clearly defining the problem and its impact, 2. Gathering and analyzing data to identify the root cause, 3. Developing and evaluating potential solutions, 4. Implementing the chosen solution with appropriate testing and validation, and 5. Monitoring the effectiveness of the corrective action and making adjustments as needed. This process ensures that actions are not only effective in addressing the immediate issue, but also contribute to long-term quality improvement and maintain compliance with relevant standards and regulations. Question 3. System analysis indicates that a software development team has logged 500 defects over the past 6 months. The defects vary in severity and are reported by different testing phases and user groups. The team is facing pressure to improve the overall stability of the software for an upcoming release. The quality manager needs to decide on the most effective strategy for defect remediation to maximize the impact on software quality within the remaining development cycle. Which of the following approaches best aligns with the principles of efficient defect management and the Pareto principle for improving software quality? Option A. Focus remediation efforts on defects reported by the most senior or influential stakeholders, as their feedback is considered the highest priority. Option B. Address defects in the order they were reported, ensuring that each defect is resolved before moving to the next, regardless of its type or severity. Option C. Analyze the defect logs to identify the most frequently occurring defect types and their associated impact. Then prioritize remediation efforts on these vital few defect categories. Option D. Attempt to fix every single defect logged, aiming for a zero defect state before the release, even if it requires significant additional time and resources. The correct answer is C. Analyze the defect logs to identify the most frequently occurring defect types and their associated impact. Then prioritize remediation efforts on these vital few defect categories. Explanation. This scenario presents a common challenge in software quality management, effectively leveraging defect data to drive improvement. The professional challenge lies in moving beyond simply identifying defects to strategically prioritizing remediation efforts based on their impact and frequency, aligning with the principles of efficient resource allocation and risk mitigation. Careful judgment is required to ensure that the chosen approach not only addresses the most critical issues, but also adheres to the established quality management framework and any relevant regulatory guidelines for software development and deployment. The correct approach involves applying the Pareto principle, 80/20 rule, to defect data, identifying the vital few defect types that contribute to the majority of software failures or issues. This strategy focuses resources on addressing the root causes of these high-impact defects, leading to a disproportionately large improvement in overall software quality. This aligns with the principles of effective quality management, emphasizing proactive problem-solving and continuous improvement. While the CMSQ certification itself does not mandate specific external regulations, its curriculum emphasizes best practices that are often implicitly or explicitly required by industry standards and client contracts, such as ISO 9001 or similar quality management systems, which advocate for data-driven decision-making and risk-based approaches to quality assurance. Focusing on defect clustering and the Pareto principle is a direct application of these principles, ensuring that the most significant quality risks are addressed first. An incorrect approach would be to address defects solely based on their chronological order of discovery or by the team that reported them. This fails to acknowledge the principle of defect clustering and the Pareto distribution, leading to inefficient use of resources. It risks spending significant effort on minor issues while neglecting the root causes of major problems, thus not achieving the most impactful quality improvements. This approach lacks a data-driven, risk-based methodology, which is a cornerstone of professional software quality management. Another incorrect approach would be to prioritize defects based on the subjective opinion of the most vocal stakeholder, without objective data to support the prioritization. While stakeholder feedback is important, relying solely on subjective influence rather than empirical data can lead to misallocation of resources and may not address the most technically significant or frequently occurring defects. This approach deviates from a systematic, evidence-based quality management process. A third incorrect approach would be to attempt to fix every single defect, regardless of its severity or frequency, before releasing the software. This zero-defect mentality, while seemingly ideal, is often impractical and economically unfeasible. It can lead to significant delays in delivery and may not be the most effective use of resources, especially when a small number of defect types are responsible for the vast majority of issues. Professional decision-making requires a pragmatic, risk-informed approach that balances quality objectives with project constraints. A professional decision-making process for similar situations should involve 1. Data collection and analysis. Systematically gather defect data, categorizing defects by type, severity, and frequency. 2. Pareto analysis. Apply the Pareto principle to identify the defect clusters that contribute most significantly to overall issues. 3. Root cause analysis. Investigate the underlying causes of the high-priority defect clusters. 4. Prioritization and planning. Develop a remediation plan that focuses resources on addressing the identified root causes and high-impact defects. 5. Continuous monitoring. Track defect trends and the effectiveness of remediation efforts to ensure ongoing quality improvement. This structured, data-driven approach ensures that quality efforts are targeted, efficient, and aligned with achieving the most significant improvements. Question 4. Cost-benefit analysis shows that implementing a full suite of boundary value tests for every single input field in a complex enterprise application would significantly delay the release and exceed the allocated testing budget. As the Certified Manager of Software Quality, CMSQ, what is the most appropriate approach to ensure quality while managing project constraints, adhering to best practices and potential regulatory expectations? Option A. Skip boundary value analysis for all input fields to meet the release deadline and stay within budget, relying on other testing methods. Option B. Rely exclusively on exploratory testing for all input fields, assuming that experienced testers will naturally identify boundary-related issues. Option C. Apply boundary value analysis exhaustively to every input field to guarantee maximum test coverage, even if it means a significant delay and budget overrun. Option D. Prioritize boundary value analysis for critical input fields and apply a risk-based testing strategy for less critical fields, potentially using equivalence partitioning or exploratory testing. The correct answer is D. Prioritize boundary value analysis for critical input fields and apply a risk-based testing strategy for less critical fields, potentially using equivalence partitioning or exploratory testing. Explanation. Scenario analysis. This scenario presents a common challenge in software quality management where a trade-off exists between thoroughness of testing and project timelines/resources. The pressure to deliver quickly can lead to the temptation to cut corners on testing, particularly in areas that might seem less critical or more time-consuming to test exhaustively. The professional challenge lies in balancing the need for robust quality assurance, which is paramount for regulatory compliance and user trust, against the business imperative of timely delivery. A manager must make a judgment call that upholds quality standards while remaining pragmatic about project constraints. Correct approach analysis. The correct approach involves prioritizing boundary value analysis for critical input fields, especially those with defined numerical or character limits, and applying a more heuristic or risk-based approach to less critical fields. This is the best professional practice because it directly addresses the highest risk areas for defects. Boundary value analysis is a proven technique for uncovering errors that often occur at the edges of valid input ranges. By focusing these efforts on critical fields, the manager ensures that the most impactful potential issues are addressed. This aligns with the principles of efficient and effective testing, maximizing the return on testing investment. From a regulatory perspective, particularly in sectors with stringent quality requirements, e.g., finance, healthcare, where CMSQ certifications are often relevant, demonstrating a systematic and risk-aware approach to testing is crucial for compliance. The CMSQ framework emphasizes a pragmatic and risk-based approach to quality management, ensuring that resources are allocated where they will have the greatest impact on product quality and safety. Incorrect approaches analysis. One incorrect approach is to skip boundary value analysis entirely for all input fields to save time. This is a significant regulatory and ethical failure. It demonstrates a disregard for established best practices in software testing and a failure to adequately mitigate known sources of defects. Such an approach increases the likelihood of releasing software with critical bugs, potentially leading to financial losses, reputational damage, and non-compliance with industry-specific regulations that mandate certain levels of software quality and reliability. Another incorrect approach is to apply boundary value analysis exhaustively to every single input field, regardless of its criticality. Seemingly thorough, this approach is inefficient and can lead to wasted resources. It fails to acknowledge the risk-based principles inherent in effective quality management. The CMSQ framework promotes intelligent allocation of resources, not brute force application of techniques. This inefficiency can delay critical releases and strain project budgets, indirectly impacting the overall quality and sustainability of the software product. A third incorrect approach is to rely solely on exploratory testing for all input fields, assuming that experienced testers will naturally uncover boundary issues. While exploratory testing is valuable, it is not a substitute for structured techniques like boundary value analysis, especially for critical inputs. Exploratory testing is less predictable and may miss specific boundary-related defects that a systematic approach would uncover. This can lead to regulatory noncompliance if the chosen testing methods are deemed insufficient for the risk profile of the software. Professional reasoning. Professionals should employ a decision-making framework that begins with understanding the regulatory landscape and the specific quality requirements for the software under development. Next, they should assess the risk associated with different input fields, considering factors like data sensitivity, potential impact of errors, and historical defect data. This risk assessment informs the prioritization of testing techniques. Boundary value analysis should be applied strategically to high-risk input fields. For lower-risk fields, a combination of equivalence partitioning and potentially less intensive testing methods can be employed. The decision-making process should be documented, including the rationale for the chosen testing strategy, to demonstrate due diligence and compliance. Question 5. Strategic planning requires a software quality manager to ensure that the development of a new financial reporting application adheres to all relevant U.S. Securities and Exchange Commission (SEC) regulations concerning data integrity and audit trails. Which of the following approaches best aligns with the principles of regulatory compliance and effective software quality management for this scenario? Option A. Integrate regulatory requirement analysis and compliance testing into each phase of the software development lifecycle, SDLC, ensuring that quality gates are established to verify adherence to SEC mandates before proceeding to the next stage. Option B. Prioritize the implementation of features deemed most critical by stakeholders, deferring detailed documentation of compliance-related processes until after the initial product launch. Option C. Focus primarily on meeting the aggressive release deadline, with a plan to address any potential regulatory compliance gaps through post-release patches and updates as identified by the compliance team. Option D. Implement a comprehensive suite of automated tests only after the application has been fully developed, relying on the development team's self-assessment for initial quality assurance. The correct answer is A. Integrate regulatory requirement analysis and compliance testing into each phase of the software development lifecycle, SDLC, ensuring that quality gates are established to verify adherence to SEC mandates before proceeding to the next stage. Explanation. This scenario is professionally challenging because it requires a software quality manager to balance the immediate need for a product release with the long-term implications of regulatory compliance and the integrity of the software. The pressure to meet deadlines can lead to shortcuts that compromise quality and introduce significant risks, including potential legal repercussions and damage to the organization's reputation. Careful judgment is required to ensure that quality is not sacrificed for speed, especially when regulatory frameworks are involved. The correct approach involves a proactive and integrated strategy for quality assurance that is embedded within the software development lifecycle, aligning with the principles of the Certified Manager of Software Quality (CMSQ) framework. This approach prioritizes understanding and adhering to relevant regulatory requirements from the outset of planning. It emphasizes building quality into the process, rather than attempting to inspect it in at the end. This includes establishing clear quality metrics, implementing robust testing procedures, and ensuring comprehensive documentation that demonstrates compliance. For a CMSQ, this means leveraging established quality models and standards that are recognized within the relevant jurisdiction to guide development and verification activities. The ethical and regulatory justification lies in the responsibility to deliver software that is not only functional, but also safe, secure, and compliant with all applicable laws and industry standards, thereby protecting users and the organization. An incorrect approach that focuses solely on meeting the release deadline without adequate consideration for regulatory compliance would be professionally unacceptable. This failure stems from a disregard for the legal and ethical obligations to produce software that meets established quality and safety standards. Such an approach risks significant penalties, product recalls, and reputational damage. Another incorrect approach that involves implementing quality checks only after the development phase is complete is also flawed. This reactive strategy is inefficient and often leads to costly rework and delays. It fails to embed quality into the development process, increasing the likelihood of defects and noncompliance being discovered late, when remediation is most difficult and expensive. This approach neglects the principle of continuous improvement and early defect detection, which are fundamental to effective software quality management. A third incorrect approach that relies on anecdotal evidence or the subjective opinion of team members regarding quality, without objective metrics or adherence to documented processes, is professionally unsound. This approach lacks the rigor required for demonstrating compliance and ensuring consistent quality. It opens the door to bias and inconsistency, making it impossible to reliably assess the software's adherence to regulatory requirements or to provide auditable evidence of quality assurance activities. The professional decision-making process for similar situations should involve a thorough risk assessment that explicitly includes regulatory compliance as a critical factor. A software quality manager must advocate for the integration of quality assurance activities throughout the entire development lifecycle, ensuring that all regulatory requirements are identified, understood, and addressed from the project's inception. This involves fostering a culture of quality within the development team and establishing clear communication channels with stakeholders to manage expectations regarding timelines and quality deliverables. When faced with pressure to compromise on quality for speed, the manager must be prepared to articulate the risks associated with noncompliance and propose alternative solutions that uphold both quality and regulatory integrity. Question 6. Stakeholder feedback indicates a desire to accelerate the release of a critical financial reporting module, with some suggesting that current testing efforts are overly time-consuming and that the software appears stable. As the certified manager of software quality, how should you best address the black box testing strategy for this module to balance release timelines with the imperative for robust quality assurance and regulatory compliance? Option A. Prioritize testing efforts solely on the features that stakeholders identify as most frequently used, assuming other areas are less likely to contain significant defects. Option B. Focus exclusively on decision table testing for all aspects of the financial reporting module, as it provides a comprehensive view of input-action relationships. Option C. Systematically apply equivalence partitioning and boundary value analysis to the input domain of the financial reporting module, prioritizing test cases based on risk and complexity, and supplement with decision table testing for complex business rules. Option D. Conduct extensive ad hoc exploratory testing, relying on the team's experience to uncover any remaining critical defects before release. Correct answer is C. Systematically apply equivalence partitioning and boundary value analysis to the input domain of the financial reporting module, prioritizing test cases based on risk and complexity, and supplement with decision table testing for complex business rules. Explanation. Scenario analysis. This scenario presents a common challenge in software quality management, where conflicting stakeholder priorities can impact testing strategies. The pressure to accelerate delivery, coupled with a perceived lack of critical defects, necessitates a robust and defensible approach to black box testing. The challenge lies in balancing the need for thoroughness with efficiency, ensuring that testing efforts are both effective and aligned with regulatory expectations for software quality and safety, particularly in a regulated industry where compliance is paramount. The CMSQ certification implies a need to adhere to established quality management principles and potentially industry-specific regulations that mandate certain levels of testing rigor. Correct approach analysis. The correct approach involves prioritizing and systematically applying black box testing techniques like equivalence partitioning and boundary value analysis to identify potential defect classes and edge cases. Equivalence partitioning groups similar input data, reducing the number of test cases while ensuring coverage of distinct input behaviors. Boundary value analysis focuses on the edges of equivalence partitions, where errors are statistically more likely to occur. This systematic application, guided by the software's requirements and design specifications, directly supports the CMSQ mandate to ensure software quality and reliability. Regulatory frameworks often implicitly or explicitly require a risk-based and comprehensive testing approach that minimizes the likelihood of critical defects reaching end users. By focusing on these proven techniques, the team demonstrates a commitment to a structured, evidence-based testing process that is more likely to uncover defects than ad hoc methods, thereby upholding professional responsibility and potentially meeting regulatory compliance standards for defect prevention and detection. Incorrect approaches analysis. Focusing solely on decision table testing without considering equivalence partitioning or boundary value analysis is an incomplete approach. While decision tables are excellent for testing complex business rules with multiple conditions and actions, they can become unwieldy and may not adequately cover all input domain variations if not complemented by other techniques. This can lead to missed defect classes. Relying exclusively on ad hoc exploratory testing while valuable for uncovering unexpected issues, lacks the systematic rigor expected in a regulated environment. It is difficult to demonstrate comprehensive coverage or to justify the testing effort against specific requirements or potential risks, which could be a failure to meet regulatory expectations for documented and repeatable testing processes. Prioritizing only the most frequently used features based on stakeholder perception, without a structured analysis of the input domain, risks overlooking critical but less frequently exercised functionalities, where significant defects might reside. This approach fails to address the full scope of potential risks and may not satisfy regulatory requirements for thoroughness. Professional reasoning. Professionals in software quality management must adopt a risk-based and systematic approach to testing. When faced with pressure to accelerate delivery, the decision-making process should involve 1. Understanding the regulatory context and any specific testing mandates. 2. Analyzing the software's requirements and design to identify potential defect areas. 3. Selecting and applying appropriate black box testing techniques, equivalence partitioning, boundary value analysis, decision tables, in a structured manner to maximize defect detection efficiency. 4. Documenting the testing strategy, test cases, and results to provide auditable evidence of quality assurance efforts. 5. Communicating the rationale behind the chosen testing approach to stakeholders, explaining how it balances efficiency with the need for quality and compliance. Question 7. Strategic planning requires a certified manager of software quality, CMSQ, to select an agile methodology that best supports the integration of quality assurance and regulatory compliance. Considering the CMSQ exam's jurisdiction, which of the following approaches best aligns with ensuring demonstrable quality and adherence to regulatory frameworks while leveraging agile principles? Option A. Utilizing extreme programming, XP, practices like pair programming and TDD, without explicitly mapping their outputs to specific regulatory compliance documentation requirements. Option B. Implementing Scrum with a strong emphasis on defining definition of done, to include comprehensive quality checks and integrating quality metrics into sprint reviews and retrospectives. Option C. Employing a hybrid approach that mixes elements of Scrum and Kanban, but lacks a clear, unified strategy for quality assurance and regulatory oversight. Option D. Adopting Kanban for its workflow visualization and throughput optimization, with quality checks being ad hoc and dependent on individual developer discretion. Correct answer is B. Implementing Scrum with a strong emphasis on defining definition of done, to include comprehensive quality checks and integrating quality metrics into sprint reviews and retrospectives. Explanation. This scenario is professionally challenging because it requires a software quality manager to balance the inherent flexibility of agile methodologies with the need for demonstrable compliance and auditable quality assurance processes, particularly within a regulated environment. The manager must ensure that the chosen agile framework, while promoting rapid iteration and customer feedback, does not inadvertently compromise the integrity, security, or reliability of the software, which could lead to regulatory noncompliance and potential harm. Careful judgment is required to select and adapt agile practices that align with the specific quality and regulatory demands of the CMSQ exam's jurisdiction. The correct approach involves integrating quality assurance activities directly into the Scrum framework's iterative cycles. This means ensuring that definition of done includes robust quality checks, that testing is continuous and automated where possible, and that quality metrics are tracked and reviewed during sprint retrospectives. This approach is right because Scrum, when properly implemented with quality in mind, provides a structured yet adaptable way to manage software development. Regulatory frameworks often emphasize continuous improvement and risk mitigation, which are facilitated by Scrum's feedback loops and iterative nature. By embedding quality into each sprint, the team can identify and address defects early, reducing the risk of major issues later in the development lifecycle, and ensuring that the software meets defined quality standards and regulatory requirements. This proactive quality integration is a cornerstone of responsible software management. An incorrect approach would be to adopt Kanban solely for its flow efficiency, without establishing clear quality gates or defined acceptance criteria for work items. While Kanban excels at visualizing workflow and limiting work in progress, its inherent flexibility can lead to a lack of structured quality assurance if not deliberately augmented. This failure is regulatory and ethical, because it risks producing software that may not meet mandated quality standards or pass necessary audits, potentially violating regulations that require demonstrable quality and risk management. Another incorrect approach would be to implement extreme programming, XP, practices like pair programming and test-driven development, TDD, but without a clear strategy for how these practices contribute to meeting specific regulatory compliance objectives or how their outcomes will be documented for audit purposes. While XP is strong on technical quality, a failure to connect these practices to broader compliance requirements means that the software might be technically sound, but still non-compliant with industry-specific regulations or data privacy laws. This represents an ethical failure in ensuring the software is not only functional but also legally and ethically sound. The professional decision-making process for similar situations should involve 1. Understanding the specific regulatory landscape and quality requirements mandated by the CMSQ exam's jurisdiction. 2. Evaluating the strengths and weaknesses of different agile methodologies, Scrum, Kanban, XP, in relation to these requirements. 3. Selecting an agile framework that best supports the integration of quality assurance and compliance activities. 4. Adapting the chosen framework to incorporate necessary quality gates, documentation, and audit trails. 5. Continuously monitoring and measuring the effectiveness of the integrated quality processes and making adjustments as needed. 6. Ensuring that all team members understand their roles and responsibilities in maintaining software quality and regulatory compliance. Question 8. Investigation of a critical software release for a medical device manufacturer reveals that several high-priority defects have been identified during the final testing phase. The project manager, citing aggressive market launch deadlines, is pushing for the release of the software with a plan to address the defects in a subsequent patch. As a certified manager of software quality, CMSQ, you are responsible for ensuring the software meets all applicable regulatory requirements and quality standards. Which of the following actions best reflects your responsibilities and ethical obligations in this scenario, adhering strictly to the principles of software quality management within a regulated environment? Option A. Document all identified high-priority defects, their potential impact on patient safety and device functionality, and present a detailed risk assessment to the project manager and relevant stakeholders, recommending a delay in the release until these defects are resolved or adequately mitigated. Option B. Inform the project manager that the release cannot proceed due to the identified defects and cease all further involvement in the release process until the defects are fixed. Option C. Agree to the release, but only if the project manager provides a written waiver absolving you and the quality assurance team of any responsibility for issues arising from the known defects. Option D. Proceed with the release as requested by the project manager, assuming that the subsequent patch will rectify any issues, and focus on documenting the defects for future reference. The correct answer is A. Document all identified high-priority defects, their potential impact on patient safety and device functionality, and present a detailed risk assessment to the project manager and relevant stakeholders, recommending a delay in the release until these defects are resolved or adequately mitigated. Explanation. This scenario presents a professional challenge due to the inherent conflict between the perceived urgency of a release and the established quality assurance processes designed to ensure software reliability and compliance. The SQA engineer is tasked with balancing the business's need for rapid deployment against the regulatory mandate to deliver safe and effective software. This requires careful judgment to uphold quality standards without unduly impeding progress, necessitating a deep understanding of the SQA engineer's responsibilities, skills, and experience within the specified regulatory framework. The correct approach involves the SQA engineer meticulously documenting the identified risks, their potential impact, and proposing mitigation strategies. This aligns with the core responsibilities of an SQA engineer to act as a gatekeeper for quality and to provide objective assessments of software readiness. The regulatory framework for software quality, particularly in regulated industries, mandates thorough risk assessment and management. By documenting findings and recommending actions, the SQA engineer fulfills their ethical and professional obligation to ensure that the software meets established quality and safety standards before release, thereby protecting end users and the organization from potential liabilities. This proactive stance is crucial for maintaining compliance and fostering a culture of quality. An incorrect approach would be to bypass the established testing procedures due to time pressure. This directly violates the SQA engineer's responsibility to ensure that all critical quality gates are met. Ethically, this could lead to the release of faulty software, potentially causing harm or financial loss, and would certainly breach regulatory requirements for due diligence in software development. Another incorrect approach would be to simply refuse to participate in the release discussions without providing any reasoned justification or alternative solutions. While it upholds the principle of not compromising quality, it fails to demonstrate the collaborative problem-solving expected of an SQA engineer. A professional SQA engineer should not only identify issues, but also contribute to finding solutions, even under pressure. This approach lacks the proactive and constructive engagement required to navigate such challenging situations effectively. A further incorrect approach would be to agree to the release without fully understanding or communicating the residual risks. This demonstrates a lack of technical rigor and a failure to uphold the SQA engineer's duty to provide an accurate assessment of the software's quality. It prioritizes expediency over responsibility, which is a direct contravention of professional ethics and regulatory expectations for quality assurance. A professional decision-making process in such situation should involve a structured approach. First, thoroughly understand the requirements and constraints. Second, objectively assess the software against quality criteria and regulatory mandates. Third, clearly communicate identified risks and their potential impact. Fourth, propose actionable mitigation strategies. And finally, collaborate with stakeholders to reach an informed decision that balances quality, risk, and business objectives. This process ensures that decisions are data-driven, ethically sound, and compliant with the relevant regulatory framework. Question 9. The control framework reveals that a software development organization is struggling with inconsistent product quality and frequent project delays. As a certified manager of software quality, CMSQ, which approach best aligns with the principles of CMMI to address these systemic issues and improve overall software quality. Option A. Focus on improving the requirements management and verification process areas to ensure that software is built correctly from the outset and that its adherence to requirements is systematically checked throughout development. Option B. Implement a rigorous, independent testing phase at the end of each development cycle to catch as many defects as possible before release. Option C. Introduce a comprehensive defect tracking system and mandate that all developers log every bug found, prioritizing the resolution of the highest number of reported defects. Option D. Pursue immediate certification at a higher CMMI maturity level to signal improved quality to external stakeholders, regardless of the specific process improvements required. The correct answer is B. Implement a rigorous, independent testing phase at the end of each development cycle to catch as many defects as possible before release. Explanation: this scenario is professionally challenging because it requires a certified manager of software quality, CMSQ, to balance the immediate pressures of project delivery with the long-term strategic benefits of process improvement, specifically within the context of CMMI. The CMSQ must understand how different CMMI levels and their associated process areas directly impact software quality, and consequently, regulatory compliance and customer satisfaction. The challenge lies in advocating for and implementing process improvements that may initially seem to slow down development, but are essential for achieving higher maturity levels and sustained quality. The correct approach involves leveraging the CMMI framework to identify specific process areas that, when improved, will yield the most significant gains in software quality and predictability. This aligns with the core principles of CMMI, which aims to institutionalize best practices to achieve predictable outcomes. By focusing on process areas like requirements management, configuration management, and verification, the CMSQ can demonstrate a clear path to reducing defects, improving traceability, and ensuring that the software meets its intended specifications. This proactive approach to quality management is not only a best practice, but also often a de facto requirement for organizations operating in regulated industries where demonstrable quality processes are paramount. The CMSQ role is to translate CMMI principles into tangible improvements that satisfy both internal quality objectives and external regulatory expectations. An incorrect approach that focuses solely on immediate defect reduction without addressing the underlying process issues, fails to leverage the strategic value of CMMI. While defect reduction is a desirable outcome, it is a symptom of process maturity, not the cause. Without improving process areas like causal analysis and prevention or process and product quality assurance, the organization will likely continue to experience recurring issues, leading to a reactive rather than proactive quality posture. This can lead to regulatory scrutiny if the organization cannot demonstrate a systematic approach to quality. Another incorrect approach that prioritizes achieving a higher CMMI level for prestige or external validation, without a clear understanding of how specific process areas contribute to actual quality improvement, is also flawed. CMMI levels are a consequence of well-implemented processes, not an end in themselves. Focusing on the level, without understanding the capability of the underlying processes, can lead to superficial improvements that do not translate into sustained quality gains. This can result in a failure to meet regulatory requirements for robust quality management systems, as the organization may appear to have a framework but lack the substance. A third incorrect approach that neglects the impact of process areas on the entire software development lifecycle, focusing only on a single phase, misses the integrated nature of CMMI. For example, focusing solely on testing without improving requirements management or design processes will lead to a bottleneck and will not address the root causes of defects. This fragmented approach undermines the holistic quality improvements that CMMI aims to achieve and can lead to non-compliance with regulations that expect end-to-end quality assurance. The professional decision-making process for similar situations should involve 1. Understanding the organization's current maturity level and quality challenges. 2. Identifying specific CMMI process areas that directly address these challenges and offer the greatest potential for quality improvement. 3. Developing a phased implementation plan that prioritizes process areas based on their impact and feasibility. 4. Quantifying the expected benefits of process improvements in terms of defect reduction, cycle time, and customer satisfaction. 5. Communicating the value of process improvement to stakeholders, linking it to business objectives and regulatory compliance. 6. Continuously monitoring and measuring the effectiveness of implemented processes and making adjustments as needed. Question 10. The risk matrix shows a moderate likelihood of regulatory noncompliance due to insufficient quality assurance oversight on a critical software project. As the Certified Manager of Software Quality, CMSQ, which of the following approaches best aligns with defining SQA activities, roles, and responsibilities to mitigate this risk, considering U.S. regulatory frameworks? Option A. Rely on the General Project Management Plan to implicitly cover SQA needs, assuming that standard project controls will ensure adequate quality without explicit SQA activity definition or role assignment. Option B. Proactively collaborate with development, project management, and end-user representatives to define a comprehensive SQA plan, clearly outlining specific activities, the individuals or teams responsible for each, and the required competencies, ensuring alignment with relevant U.S. quality standards and regulatory expectations. Option C. Delegate the definition of SQA activities and responsibilities entirely to the lead developer, assuming they possess the necessary expertise to cover all quality aspects relevant to regulatory compliance. Option D. Postpone detailed SQA planning until the later stages of development, focusing primarily on immediate coding tasks to meet aggressive deadlines and address quality concerns reactively as they arise. The correct answer is B. Proactively collaborate with development, project management, and end-user representatives to define a comprehensive SQA plan, clearly outlining specific activities, the individuals or teams responsible for each, and the required competencies, ensuring alignment with relevant U.S. quality standards and regulatory expectations. Explanation. This scenario is professionally challenging because it requires balancing the immediate need for software development with the long-term implications of inadequate quality assurance planning. The Certified Manager of Software Quality, CMSQ, is responsible for ensuring that quality is built into the software development lifecycle, not just tested at the end. The pressure to deliver quickly can lead to shortcuts that compromise compliance and stakeholder trust. Careful judgment is required to advocate for necessary SQA activities while understanding business constraints. The correct approach involves proactively engaging all relevant stakeholders, including the development team, project management, and end users to define SQA activities, roles, and responsibilities collaboratively. This ensures that SQA is integrated into the project plan from the outset, aligning with regulatory requirements and business objectives. Specifically, for a CMSQ operating under U.S. regulations, this means adhering to frameworks like the Software Engineering Institute's Capability Maturity Model Integration, CMI, or relevant NIST guidelines, which emphasize process definition and institutionalization. By establishing clear roles and responsibilities, the CMSQ ensures accountability and that SQA activities are performed by competent individuals, thereby mitigating risks and ensuring compliance with quality standards mandated by regulations, such as those overseen by the FDA for medical devices or the SEC for financial software. An incorrect approach that prioritizes immediate development over SQA planning fails to establish a robust quality framework. This can lead to significant regulatory noncompliance, as many U.S. regulations require documented quality processes and evidence of their execution. For example, neglecting to define SQA roles and responsibilities means that critical quality tasks might be overlooked or performed by individuals lacking the necessary expertise, increasing the likelihood of defects and potential safety or security breaches, which would violate the intent of quality assurance mandates. Another incorrect approach, which is to delegate SQA planning solely to the development team without proper oversight or integration with other stakeholders, is also professionally unacceptable. While developers are crucial to quality, they may not have the holistic perspective required to define comprehensive SQA activities that satisfy all regulatory and business needs. This can result in a narrow focus on code-level quality, potentially ignoring broader system-level risks, usability, or security requirements that are often subject to specific regulatory scrutiny. A third incorrect approach, which is to assume that existing general project management processes will automatically cover SQA needs, is equally flawed. General project management focuses on scope, schedule, and budget. While these are important, they do not inherently define the specific, often technical and process-oriented, activities required for software quality assurance as mandated by various U.S. regulatory bodies. Without explicit definition and assignment of SQA roles and responsibilities, quality assurance becomes an afterthought, increasing the risk of non-compliance and product failure. The professional decision-making process for similar situations should involve a risk-based approach. First, identify all applicable regulatory requirements related to software quality for the specific industry. Second, engage all key stakeholders to understand their quality expectations and concerns. Third, collaboratively define the necessary SQA activities, ensuring they are integrated into the project lifecycle. Fourth, clearly assign roles and responsibilities for these activities, ensuring individuals have the necessary skills and authority. Finally, document this SQA plan and obtain stakeholder buy-in, making it a living document that is reviewed and updated as the project progresses. Question 11. When evaluating the most effective approach for managing software quality on a project characterized by evolving stakeholder requirements and significant technical unknowns, which of the following strategies best aligns with the principles of proactive risk management and continuous stakeholder engagement, as expected within the Certified Manager of Software Quality (CMSQ) framework? Option A. Prioritizing the rapid delivery of a minimum viable product (MVP) without a defined plan for subsequent iterative quality improvements or risk mitigation. Option B. Adhering strictly to a traditional waterfall methodology, assuming requirements will be finalized before development begins. Option C. Proceeding with a technically sound, predefined development plan, minimizing stakeholder interaction to avoid scope creep. Option D. Employing an iterative and incremental model that integrates prototyping for early feedback and risk analysis at each stage, akin to the spiral model. Correct answer is D. Employing an iterative and incremental model that integrates prototyping for early feedback and risk analysis at each stage, akin to the spiral model. Explanation. Scenario analysis. This scenario presents a common challenge in software quality management, where stakeholders have differing views on the best approach to manage evolving requirements and risks, particularly when dealing with innovative or complex projects. The challenge lies in balancing the need for early stakeholder feedback and risk mitigation with the potential for scope creep, and the need for a structured development process. A quality manager must navigate these differing perspectives while ensuring adherence to established quality principles and regulatory expectations, which often emphasize transparency, traceability, and demonstrable risk management. Correct approach analysis. Adopting an iterative and incremental model, specifically one that incorporates elements of prototyping and the spiral model, is the most appropriate approach. This aligns with the CMSQ emphasis on proactive risk management and continuous stakeholder engagement. Prototyping allows for early validation of user needs and technical feasibility, providing tangible artifacts for feedback. The spiral model, with its focus on risk analysis at each iteration, directly addresses the inherent uncertainties in innovative projects. This approach allows for flexibility in adapting to changing requirements while maintaining a structured process for quality assurance and regulatory compliance. The iterative nature ensures that quality is built-in throughout the lifecycle, rather than being an afterthought, which is a core tenet of modern software quality management frameworks. Incorrect approach is analysis. A purely waterfall approach would be professionally unacceptable. This model is rigid and assumes stable requirements, making it ill-suited for projects with evolving needs or significant technical unknowns. It delays stakeholder feedback until late in the development cycle, increasing the risk of delivering a product that does not meet expectations and making it difficult to incorporate necessary changes without significant rework and cost. This lack of early feedback and adaptability can lead to quality issues and non-compliance with evolving regulatory landscapes that demand responsiveness. Focusing solely on delivering a minimum viable product, MVP, without a clear plan for iterative refinement and risk assessment would also be professionally unsound. While MVPs are valuable for early market entry, a quality manager must ensure that the MVP is built on a foundation that allows for subsequent quality improvements and risk mitigation. Without a structured iterative process, an MVP can become a technically debt-ridden product that is difficult to maintain and scale, potentially leading to long-term quality failures and regulatory noncompliance if critical functionalities are compromised. Ignoring stakeholder feedback entirely and proceeding with a predefined plan, even if it appears technically sound, is a direct contravention of quality management principles and often regulatory requirements that mandate stakeholder involvement and validation. This approach fosters a disconnect between the development team and the end users or business objectives, leading to a high probability of product failure and a lack of trust, which are significant quality and ethical concerns. Professional reasoning. Professionals should employ a decision-making framework that prioritizes understanding the project's context, including its inherent risks, stakeholder expectations, and regulatory environment. When faced with evolving requirements or uncertainty, iterative and incremental models that facilitate early feedback and risk management, such as those incorporating prototyping and spiral model principles, should be favored. The decision should be driven by the potential for improved quality outcomes, reduced project risk, and enhanced stakeholder satisfaction, all while ensuring compliance with relevant standards and regulations. A thorough risk assessment and a clear communication strategy with stakeholders are paramount in selecting and implementing the most appropriate development and quality assurance approach. Question 12. Market research demonstrates that a significant portion of the target market is highly sensitive to product reliability and data security, with a strong preference for vendors with a proven track record of compliance. Your software development team is under pressure to accelerate the release timeline for a new product. You are tasked with allocating the quality budget for the upcoming development cycle. Which of the following approaches best aligns with the principles of quality management and responsible software development, considering the market feedback and the need for a timely release? Option A. Allocate the majority of the quality budget to internal failure costs, such as rework and defect correction during the development cycle, without a significant increase in preventative measures. Option B. Focus the quality budget primarily on addressing external failure costs, such as customer support for reported bugs and managing product recalls, as these are the most visible indicators of quality issues. Option C. Minimize upfront investment in prevention and appraisal activities to free up resources for faster development, with the expectation of addressing any issues that arise during the testing phase or post-release. Option D. Allocate the majority of the quality budget to robust prevention activities, such as comprehensive code reviews, static analysis, and secure coding training, and to appraisal activities, such as extensive unit and integration testing and independent security audits. correct answer is D. Allocate the majority of the quality budget to robust prevention activities, such as comprehensive code reviews, static analysis, and secure coding training, and to appraisal activities, such as extensive unit and integration testing and independent security audits. Explanation: this scenario is professionally challenging because it requires a nuanced understanding of quality costs and their strategic implications within the context of software development, specifically for a CMSQ candidate. The pressure to deliver a product quickly, coupled with the potential for significant future costs, necessitates a decision that balances immediate gains with long-term quality and compliance. Careful judgment is required to avoid short-sighted decisions that could lead to regulatory non-compliance or reputational damage. The correct approach involves prioritizing investments in prevention and appraisal activities. This strategy aligns with the fundamental principles of quality management, aiming to build quality into the software from the outset. By investing in robust development processes, thorough testing, and comprehensive reviews prevention, and by conducting rigorous inspections and audits appraisal, the likelihood of internal and external failures is significantly reduced. This proactive stance is ethically sound, as it demonstrates a commitment to delivering a reliable and compliant product, thereby protecting end users and the organization from potential liabilities. From a regulatory perspective, particularly within frameworks that emphasize due diligence and risk management in software development, such as those governing financial services or medical devices, though specific regulations are not cited here due to jurisdiction constraints. A focus on preventing defects is often implicitly or explicitly encouraged to ensure product safety and efficacy. An incorrect approach would be to minimize spending on prevention and appraisal to reduce upfront costs. This strategy, while seemingly cost-effective in the short term, directly leads to an increase in internal and external failure costs. Ethically, this is problematic as it knowingly accepts a higher risk of defects, potentially impacting users and the organization. Regulatory failures would arise if these defects lead to non-compliance with industry-specific standards or general consumer protection laws, resulting in fines, recalls, or legal action. Another incorrect approach would be to solely focus on addressing external failures as they occur. This reactive strategy is the most expensive and damaging. It implies a willingness to accept defects and deal with the consequences, which can include customer dissatisfaction, product recalls, warranty claims, and significant reputational damage. Ethically, this demonstrates a lack of responsibility towards the end user and a disregard for product integrity. Regulatory failures are almost guaranteed, as external failures often signal a breach of quality standards and contractual obligations, leading to severe penalties. A third incorrect approach would be to allocate the majority of the quality budget to internal failure costs, such as rework and scrap, without a corresponding investment in prevention. While addressing internal failures is necessary, an overemphasis on this without upstream improvements indicates a systemic problem. Ethically, it suggests an acceptance of a flawed process. Regulatory implications are less direct than external failures, but can still arise if internal failures lead to delays that impact compliance deadlines, or if the underlying process issues are a violation of quality management system requirements. The professional decision-making process for similar situations should involve a comprehensive risk assessment that quantifies the potential costs of all four categories of quality costs. This should be followed by a strategic allocation of resources that prioritizes prevention and appraisal to minimize the likelihood and impact of failures. A continuous improvement mindset, informed by data from all quality cost categories, is crucial for making informed decisions that align with both business objectives and ethical/regulatory obligations. Question 13. Analysis of the pressure to accelerate software delivery timelines within a regulated industry. Which approach to SDLC model optimization best ensures both rapid deployment and adherence to quality standards? Option A. Deferring comprehensive documentation to a post-release phase to focus on coding speed. Option B. Reducing the scope of user acceptance testing to expedite the final release. Option C. Implementing automated testing and continuous integration within an iterative SDLC model to catch defects early and often. Option D. Relying on a move fast and break things mentality with a dedicated team for post-release bug fixes. The correct answer is C. implementing automated testing and continuous integration within an iterative SDLC model to catch defects early and often. Explanation: this scenario presents a professional challenge because the organization is under pressure to deliver a software product rapidly, potentially compromising the thoroughness of its software development lifecycle (SDLC) processes. The Certified Manager of Software Quality (CMSQ) has a responsibility to ensure that quality is embedded throughout the SDLC, not just at the end, and that regulatory compliance is maintained. This requires balancing business needs for speed with the imperative for robust quality assurance and adherence to established standards. The correct approach involves a proactive and integrated strategy for process optimization within the chosen SDLC model. This means identifying critical quality checkpoints and integrating them seamlessly into the development workflow, rather than treating them as an afterthought. For example, if the organization is using an agile methodology, process optimization would focus on refining sprint reviews, retrospectives, and continuous integration/continuous delivery (CI/CD) pipelines to ensure quality feedback loops are effective and that defects are identified and addressed early. This aligns with the CMSQ role in promoting a culture of quality and ensuring that development practices meet industry standards and any applicable regulatory requirements for software quality and reliability. The ethical imperative is to deliver a product that is fit for purpose, secure, and reliable, thereby protecting users and the organization's reputation. An incorrect approach would be to solely focus on accelerating the coding phase without commensurate attention to testing, validation, or documentation. This might involve skipping or abbreviating crucial testing phases, such as unit testing, integration testing, or user acceptance testing, under the guise of efficiency. Such an approach would be ethically problematic, as it knowingly introduces risk and potentially compromises the integrity and security of the software. It would also likely violate regulatory frameworks that mandate certain levels of quality assurance and risk management for software, especially in regulated industries. Another incorrect approach would be to implement quality gates only at the very end of the development cycle, just before deployment. This is inefficient and costly, as defects found late are more expensive to fix and can cause significant delays. It also fails to embed quality throughout the process, which is a core principle of modern software quality management. This approach is not only professionally suboptimal, but also ethically questionable, as it prioritizes speed over the assurance of a quality product. A further incorrect approach would be to rely solely on post-release bug fixes to address quality issues, while bug fixing is a necessary part of the software lifecycle. Making it the primary quality strategy is a failure of proactive quality management. It implies a lack of confidence in the development and testing processes and can lead to a poor user experience, reputational damage, and potential regulatory noncompliance if the software fails to meet specified performance or safety standards. The professional decision-making process for similar situations should involve a thorough risk assessment of the proposed acceleration strategies. The CMSQ should advocate for SDLC models and practices that inherently support quality at speed, such as agile methodologies with strong CI/CD integration and automated testing. If specific regulatory requirements mandate certain documentation or testing procedures, these must be integrated into the optimized process, not bypassed. The focus should always be on achieving the desired speed without compromising the fundamental principles of software quality and regulatory adherence. Question 14. The evaluation methodology shows that the current defect reporting system indicates a very low number of reported bugs in the latest software release. However, user feedback suggests that the software is not meeting several key operational needs. Which of the following approaches best addresses this discrepancy and ensures true software quality? Option A. Increase the rigor of the defect detection process by implementing more static analysis tools and peer code reviews to uncover any remaining, albeit minor, defects. Option B. Conduct a comprehensive review of the requirements documentation to identify ambiguities, incompleteness, or misinterpretations, and then realign testing strategies to specifically validate these refined requirements. Option C. Rely on the low defect count as evidence of high quality and communicate this to stakeholders, while continuing to monitor for any new defect reports. Option D. Focus future development efforts on addressing the specific user complaints as they arise, treating them as new requirements to be implemented. The correct answer is B. Conduct a comprehensive review of the requirements documentation to identify ambiguities, incompleteness, or misinterpretations, and then realign testing strategies to specifically validate these refined requirements. Explanation. The evaluation methodology shows a common pitfall in software quality management: the absence of errors fallacy, where teams mistakenly believe that a lack of reported defects equates to a high-quality, requirement-compliant product. This scenario is professionally challenging because it requires a quality manager to look beyond superficial metrics and critically assess the underlying effectiveness of the requirements themselves and the testing strategies employed. The pressure to demonstrate progress through defect counts can mask fundamental issues with requirement clarity, completeness, and test coverage, leading to a false sense of security. The correct approach involves a proactive impact assessment focused on the right requirements. This means not just identifying and fixing defects, but also evaluating the quality of the requirements documentation itself, and ensuring that testing adequately validates those requirements against intended business objectives and user needs. This approach aligns with the principles of robust software quality management, which emphasizes preventing defects by ensuring clear, testable, and complete requirements from the outset. Regulatory frameworks and industry best practices for software quality, such as those implicitly expected in a CMSQ certification context, mandate a focus on the entire software development lifecycle, including the critical upstream phases of requirements engineering. Ethical considerations also demand that quality managers ensure products meet their intended purpose and do not pose risks due to poorly defined or inadequately tested functionalities. An incorrect approach would be to solely rely on defect density as a measure of quality. This fails to address the possibility that the requirements themselves are flawed, ambiguous, or incomplete, leading to a system that functions correctly according to those flawed requirements, but does not meet actual user needs or business goals. This can result in significant rework, customer dissatisfaction, and potential noncompliance with regulatory obligations that mandate fitness for purpose. Another incorrect approach is to focus testing efforts only on areas where defects have historically been found, neglecting new or complex functionalities. This creates blind spots and increases the risk of undetected critical issues, violating the professional duty to ensure comprehensive quality assurance. Professionals should employ a decision-making framework that prioritizes understanding the why behind the software's development. This involves 1. Thoroughly reviewing requirements for clarity, completeness, testability, and alignment with business objectives. 2. Designing test strategies that not only identify defects, but also validate that the software meets the defined requirements and user expectations. 3. Continuously assessing the effectiveness of the testing process in uncovering potential issues early. 4. Communicating risks associated with requirement quality and test coverage transparently to stakeholders. This systematic approach ensures that quality efforts are directed towards achieving true software quality, not just the absence of easily detectable errors. Question 15. Stakeholder feedback indicates a desire to expedite the release of a new software module, potentially by reducing the scope of certain risk mitigation activities identified during the initial assessment phase. As the certified manager of software quality, which approach best upholds the principles of responsible software quality management and regulatory compliance? Option A. Proceed with the expedited release, assuming that the identified risks are unlikely to materialize given the module's perceived simplicity. Option B. Inform stakeholders that the expedited release is not possible without completing all original risk mitigation activities, regardless of their perceived importance or cost. Option C. Conduct a revised risk assessment that quantifies the potential impact of expediting the release and the residual risks associated with reduced mitigation, presenting these findings to stakeholders for an informed decision on acceptable risk levels. Option D. Immediately approve the expedited release, prioritizing stakeholder satisfaction and market timing over the identified risk mitigation activities. The correct answer is C. Conduct a revised risk assessment that quantifies the potential impact of expediting the release and the residual risks associated with reduced mitigation, presenting these findings to stakeholders for an informed decision on acceptable risk levels. Explanation. This scenario is professionally challenging because it requires balancing competing stakeholder priorities and ensuring that risk assessment, a fundamental component of software quality management, is conducted effectively and ethically within the specific regulatory framework of the Certified Manager of Software Quality (CMSQ) exam. The CMSQ certification implies adherence to a set of professional standards and potentially specific regulatory guidelines relevant to software quality assurance in a given jurisdiction. Without a specified jurisdiction, we will assume a general, best practice approach aligned with common quality management principles and ethical considerations applicable to software development and assurance. The core challenge lies in ensuring that the risk assessment process is not compromised by external pressures or internal biases, thereby safeguarding the integrity of the software quality assurance process. The correct approach involves a systematic and documented risk assessment process that identifies, analyzes, and prioritizes potential risks to software quality throughout its lifecycle. This process should involve all relevant stakeholders, but the ultimate responsibility for the integrity of the risk assessment lies with the quality management team. This approach is correct because it aligns with established quality management frameworks e.g. ISO 9001 principles. Though not explicitly stated as the jurisdiction, these are foundational and ethical obligations to deliver reliable and secure software. A robust risk assessment ensures that resources are allocated effectively to mitigate the most significant threats to quality, thereby protecting users and the organization. It also provides a defensible basis for decisions regarding testing, deployment, and ongoing maintenance. An incorrect approach that focuses solely on immediate stakeholder demands without a comprehensive risk analysis would be professionally unacceptable. This failure stems from a lack of due diligence and a potential disregard for the long-term implications of unaddressed risks. Such an approach could lead to the deployment of software with critical vulnerabilities, resulting in financial losses, reputational damage, and potential legal liabilities, all of which violate the implicit ethical duty of a quality manager to ensure product integrity. Another incorrect approach that prioritizes cost reduction over thorough risk mitigation would also be professionally unsound. While budget constraints are a reality, making decisions that knowingly increase risk to quality for the sake of short-term savings is a direct contravention of quality management principles and ethical responsibilities. This approach fails to acknowledge that the cost of fixing defects after deployment is significantly higher than addressing them during development and testing. A third incorrect approach that relies on anecdotal evidence or past assumptions without a current, data-driven risk assessment is also flawed. Software systems and their operating environments evolve. Relying on outdated information can lead to a false sense of security or an underestimation of new risks. This lack of a dynamic and evidence-based approach undermines the credibility of the quality assurance process and exposes the organization to unforeseen problems. The professional decision-making process for similar situations should involve 1. Understanding the specific regulatory and ethical obligations relevant to the software quality domain. 2. Establishing a clear, documented process for risk assessment that is integrated into the software development lifecycle. 3. Ensuring that all relevant stakeholders are consulted and their input is considered, but that the final risk assessment is based on objective analysis. 4. Prioritizing risks based on their potential impact and likelihood and developing appropriate mitigation strategies. 5. Communicating the findings of the risk assessment and the rationale for mitigation decisions clearly to all stakeholders. 6. Continuously reviewing and updating the risk assessment as the software evolves and new information becomes available. Question 16. Research into a new software project indicates that key stakeholders are expressing a strong desire to see tangible progress and are questioning the necessity of extensive unit and integration testing, suggesting a focus primarily on user acceptance testing to demonstrate functionality. As a certified manager of software quality, how should you respond to this stakeholder sentiment? Option A. Explain the critical role of unit and integration testing in identifying defects early, reducing overall development costs, and ensuring system stability, thereby advocating for their inclusion as foundational elements of the testing strategy. Option B. Agree to prioritize user acceptance testing and defer detailed unit and integration testing to a later stage, contingent on available time and resources. Option C. Propose a reduced scope for unit and integration testing, focusing only on the most critical modules as identified by the stakeholders. Option D suggests that the development team conduct informal, ad hoc testing throughout the development cycle as a substitute for formal unit and integration testing. The correct answer is A. Explain the critical role of unit and integration testing in identifying defects early, reducing overall development costs, and ensuring system stability, thereby advocating for their inclusion as foundational elements of the testing strategy. Explanation. This scenario is professionally challenging because it requires balancing the immediate need for stakeholder confidence with the long-term integrity of the software quality assurance process. Stakeholders, often focused on delivery timelines and perceived progress, may not fully grasp the nuances of different testing levels and their criticality. A quality manager must educate and guide them towards decisions that uphold rigorous testing standards, even if it means managing expectations about immediate visibility. The correct approach is to advocate for a comprehensive testing strategy that includes all relevant levels, from unit testing through acceptance testing, as mandated by industry best practices and implied by the need for robust quality management systems. This approach ensures that defects are identified and resolved at the earliest possible stage, minimizing the cost and impact of failures. Regulatory frameworks, while not always explicitly detailing testing levels, emphasize the need for effective quality control and risk management, which are inherently supported by a multi-layered testing approach. This aligns with the ethical obligation of a certified manager of software quality to ensure the delivery of reliable and secure software. An incorrect approach that prioritizes only user acceptance testing overlooks critical lower-level defects that could have significant architectural or security implications, potentially leading to costly rework or system failures. This fails to meet the implicit requirement for thorough quality assurance and could violate ethical duties to deliver fit-for-purpose software. Another incorrect approach, focusing solely on integration testing, might miss fundamental issues within individual components or end-to-end user workflows, again compromising overall software quality and potentially leading to non-compliance with quality standards. A third incorrect approach, suggesting skipping formal testing phases in favor of ad hoc testing, directly contravenes established quality management principles and the need for systematic verification and validation, risking the delivery of substandard or insecure software. Professionals should approach such situations by first understanding the stakeholders' immediate concerns and then clearly articulating the rationale behind a structured, multi-level testing strategy. This involves educating stakeholders on the risks associated with incomplete testing and demonstrating how each testing level contributes to overall product quality, security, and compliance. The decision-making process should be guided by established quality management standards and the ethical imperative to deliver high-quality software. Question 17. The audit findings indicate that the software quality metrics reporting process is inconsistent, with a tendency to highlight positive trends while downplaying or omitting data points that suggest potential issues. This approach is being justified as a way to maintain stakeholder confidence. Which of the following approaches best aligns with the principles of effective quality monitoring and regulatory compliance? Option A. Transition to a manual reporting system that allows for more subjective interpretation of metrics, enabling the team to present a more curated and positive view of software quality. Option B. Focus reporting efforts exclusively on metrics that are easily quantifiable and readily available, even if they do not fully represent the overall software quality or address potential risks identified by the audit. Option C. Implement an automated system for collecting and reporting key quality metrics, ensuring that all data, both positive and negative, is presented transparently and linked to predefined quality objectives and regulatory requirements. Option D. Continue with the current practice of selectively reporting favorable metrics to maintain stakeholder confidence, while initiating a separate, internal review of potential issues that will not be part of the formal reporting. The correct answer is C. Implement an automated system for collecting and reporting key quality metrics, ensuring that all data, both positive and negative, is presented transparently and linked to predefined quality objectives and regulatory requirements. Explanation. The audit findings indicate a potential breakdown in the software quality monitoring process, specifically concerning the tracking and reporting of quality metrics. This scenario is professionally challenging because it directly impacts the organization's ability to demonstrate compliance with quality standards, identify systemic issues, and make informed decisions about process improvements. The pressure to present favorable metrics, coupled with the complexity of data aggregation and analysis, can lead to misinterpretations or deliberate omissions. Careful judgment is required to ensure that reporting is both accurate and actionable, reflecting the true state of software quality. The correct approach involves establishing a robust, automated system for collecting and analyzing key quality metrics, ensuring that the reporting mechanism is transparent, timely, and directly linked to defined quality objectives and regulatory requirements. This approach aligns with the principles of continuous improvement and proactive risk management, which are fundamental to maintaining software quality and meeting the expectations of regulatory bodies. By focusing on objective data and consistent reporting, this method provides a reliable basis for identifying trends, pinpointing areas for improvement, and demonstrating adherence to established quality frameworks. An incorrect approach that focuses solely on reporting metrics that appear favorable without addressing underlying issues is ethically problematic. This can lead to a false sense of security, masking critical defects or process inefficiencies that could have significant consequences. Such a practice undermines the integrity of the quality management system and can result in non-compliance with regulatory mandates that require accurate and complete reporting of quality status. Another incorrect approach that relies on manual data collection and ad hoc reporting is inefficient and prone to human error. This lack of standardization makes it difficult to ensure consistency and comparability of metrics over time, hindering the ability to identify meaningful trends or to effectively communicate the quality status to stakeholders. This can also lead to missed opportunities for early intervention and corrective action, potentially resulting in regulatory scrutiny or project failures. A further incorrect approach that prioritizes reporting on easily obtainable metrics over those that are critical for assessing true software quality demonstrates a misunderstanding of the purpose of quality monitoring. This can result in a skewed perception of quality, where superficial improvements are highlighted, while deeper, more significant issues remain unaddressed, ultimately failing to meet the spirit and intent of quality assurance and regulatory oversight. The professional decision-making process in such situations should involve a thorough understanding of the relevant regulatory framework and its specific requirements for quality monitoring and reporting. It necessitates a commitment to data integrity, transparency, and the use of metrics that provide actionable insights. Professionals should prioritize the establishment of automated, standardized processes that ensure accuracy and consistency. When faced with conflicting pressures or incomplete data, the ethical imperative is to seek clarity, escalate concerns, and advocate for reporting practices that are truthful and comprehensive, even if they reveal areas needing improvement. Question 18. Comparative studies suggest that optimizing software testing processes can significantly reduce delivery times. As a certified manager of software quality, you are tasked with improving the efficiency of your team's testing cycles. Considering the need to maintain high software quality and adhere to regulatory standards, which of the following approaches would be the most professionally sound and compliant method for process optimization? Option A. Immediately cease all manual testing activities and transition to exploratory testing only, relying on developer feedback for quality assurance. Option B. Implement a comprehensive automation strategy across all test types, prioritizing speed of execution over initial validation of automation scripts. Option C. Reduce the overall number of test cases executed by 20% to meet aggressive delivery deadlines, assuming that the development team's unit tests will catch most defects. Option D. Conduct a thorough analysis of existing test cases to identify redundancies and low-value tests, and then strategically automate critical regression tests and high-risk functional areas. The correct answer is B. Implement a comprehensive automation strategy across all test types, prioritizing speed of execution over initial validation of automation scripts. Explanation: this scenario is professionally challenging because it requires a software quality manager to balance the immediate pressure for faster delivery with the long-term imperative of maintaining robust quality and compliance. The pressure to reduce testing cycles without compromising the integrity of the software or violating regulatory requirements is a common dilemma. Careful judgment is required to identify and implement process optimizations that genuinely improve efficiency without introducing unacceptable risks. The correct approach involves a systematic, data-driven evaluation of the existing testing process to identify bottlenecks and inefficiencies, followed by the implementation of targeted improvements that are validated for their effectiveness. This aligns with the principles of continuous improvement and risk management, which are fundamental to software quality assurance. Specifically, adopting a phased approach to automation, focusing on regression testing and critical path scenarios first, allows for controlled integration and validation. This methodical implementation ensures that automation efforts are effective and do not inadvertently create new quality issues or bypass necessary checks. This approach is ethically sound as it prioritizes delivering a quality product that meets user needs and regulatory standards, and it is compliant with general quality management frameworks that emphasize process improvement and risk mitigation. An incorrect approach that focuses solely on reducing the number of test cases without a corresponding analysis of their criticality or impact would be professionally unacceptable. This could lead to the omission of essential tests, increasing the risk of defects escaping into production and potentially violating regulatory requirements for software validation and reliability. Another incorrect approach, which involves implementing automation tools without proper planning, training, or integration into the existing workflow, often results in wasted resources and can even hinder the testing process. This demonstrates a lack of due diligence and a failure to manage the implementation of new technologies effectively, potentially leading to non-compliance with quality standards. A third incorrect approach, which prioritizes speed over thoroughness by skipping certain testing phases, such as performance or security testing, without a documented risk assessment and management's approval, is a direct violation of quality assurance principles and could have severe regulatory and business consequences. Professionals should approach such situations by first understanding the underlying business drivers and constraints. Then, they should leverage established quality management methodologies, e.g., ISO 9001 principles, CMMI, to analyze the current process. This involves collecting data on test execution times, defect escape rates, and resource utilization. Based on this analysis, potential optimizations should be identified, prioritized based on their potential impact and feasibility, and then piloted. The effectiveness of any implemented change must be measured and validated before full-scale adoption. This structured, evidence-based decision-making process ensures that optimizations are beneficial and do not compromise quality or compliance. Question 19. Governance review demonstrates that the current software development project, subject to the stringent regulatory framework of the Certified Manager of Software Quality, CMSQ jurisdiction, is facing significant time and budget constraints. The project team has identified that achieving truly exhaustive testing, covering every conceivable input, path, and state, is technically infeasible within the allocated resources. As the lead quality manager, what is the most appropriate decision-making framework to adopt for the remaining testing phases to ensure compliance and mitigate critical risks? Option A. Rely exclusively on automated testing scripts to cover as many scenarios as possible, assuming this will compensate for the inability to perform exhaustive manual or exploratory testing. Option B. Drastically reduce the scope of testing to meet the current deadlines, focusing only on the most basic functionalities without a formal risk assessment. Option C. Continue with the original exhaustive testing plan, requesting additional time and budget to complete it, regardless of the likelihood of approval or project feasibility. Option D. Implement a comprehensive risk-based testing strategy, prioritizing test cases based on the criticality of functionalities and the potential impact of failures on regulatory compliance and user safety. Correct answer is D. Implement a comprehensive risk-based testing strategy, prioritizing test cases based on the criticality of functionalities and the potential impact of failures on regulatory compliance and user safety. Explanation. Scenario analysis. This scenario presents a common challenge in software quality management, balancing the ideal of exhaustive testing with the practical realities of project constraints. The challenge lies in making a justifiable decision that prioritizes risk mitigation and compliance within a defined scope, rather than pursuing an unattainable absolute. The pressure to deliver within budget and schedule, while still meeting regulatory expectations, requires a nuanced understanding of testing limitations and their implications. Correct approach analysis. The correct approach involves a risk-based strategy for test case selection, prioritizing areas with the highest potential impact on critical functionalities and compliance requirements. This aligns with the principles of responsible software development and quality assurance, which acknowledge that exhaustive testing is often infeasible. By focusing on high-risk areas, the team ensures that the most critical aspects of the software are thoroughly validated against regulatory standards, thereby mitigating the most significant potential failures. This pragmatic approach demonstrates an understanding of the trade-offs inherent in software development and a commitment to achieving a defined level of quality and compliance within project constraints. Incorrect approaches analysis. One incorrect approach is to continue pursuing exhaustive testing despite clear evidence of infeasibility. This demonstrates a lack of understanding of practical limitations and can lead to project delays, budget overruns, and ultimately, a failure to deliver the software. It also risks diluting focus from critical areas by spreading resources too thinly. Another incorrect approach is to significantly reduce testing scope without a formal risk assessment or stakeholder agreement. This is ethically questionable, as it knowingly increases the risk of defects impacting users or failing regulatory audits. It bypasses established quality assurance processes and can lead to severe compliance breaches. A third incorrect approach is to rely solely on automated testing, without considering the need for exploratory or manual testing for certain complex scenarios or user experience aspects. While automation is crucial, it cannot cover all potential edge cases or usability issues, and neglecting these can lead to subtle but significant quality gaps. Professional reasoning. Professionals facing this situation should employ a decision-making framework that prioritizes risk assessment and stakeholder communication. The process involves 1. Identifying critical functionalities and regulatory requirements. 2. Assessing the potential impact and likelihood of failure for different software components and features. 3. Prioritizing test cases based on this risk assessment, focusing on areas with the highest risk. 4. Documenting the rationale for the chosen testing strategy, including any limitations and accepted risks. 5. Communicating the testing strategy and associated risks to stakeholders for informed decision-making and approval. 6. Continuously monitoring and adapting the testing approach as new risks or information emerge. Question 20. Regulatory review indicates that a critical software component for a medical device has been developed with a tight deadline. The project manager is pushing to reduce the scope of white box testing to expedite delivery, suggesting that statement coverage alone would be sufficient. As the certified manager of software quality, CMSQ, you are responsible for ensuring the software meets stringent quality and regulatory standards. Considering the potential impact of defects in medical device software, which white box testing approach should you advocate for as a minimum standard for this critical component? Option A. Advocate for branch coverage to ensure all decision outcomes are tested. Option B. Advocate for statement coverage as the primary white box testing technique. Option C. Advocate for path coverage as the sole white box testing requirement. Option D. Advocate for relying solely on black box testing techniques for this component. Correct answer is A. Advocate for branch coverage to ensure all decision outcomes are tested. Explanation. Scenario analysis. This scenario presents a common challenge in software quality management, where the pressure to deliver quickly can conflict with the need for thorough testing to ensure regulatory compliance and product reliability. The project manager's directive to prioritize speed over comprehensive coverage, particularly in a regulated environment, creates a direct conflict with the CMSQ responsibility to uphold quality standards. The challenge lies in balancing business objectives with the ethical and regulatory imperative to deliver safe and effective software. The CMSQ must navigate this tension by advocating for appropriate testing methodologies that meet both functional requirements and the stringent demands of the regulatory framework. Correct approach analysis. The correct approach involves advocating for and implementing branch coverage as a minimum standard for critical components. Branch coverage ensures that every possible outcome of a decision point, e.g., if-then-else statements, is tested. This is crucial because it directly addresses the potential for errors in logical flow, which can lead to incorrect behavior or security vulnerabilities. In a regulated environment, demonstrating that all logical paths have been exercised is often a de facto requirement for proving due diligence and ensuring the software functions as intended under all foreseeable conditions. This approach aligns with the CMSQ ethical obligation to ensure software quality and safety, and it provides a defensible position when demonstrating compliance to auditors or regulatory bodies. Incorrect approach is analysis. Prioritizing statement coverage alone is an insufficient approach. While statement coverage ensures that every executable line of code is run at least once, it does not guarantee that all decision outcomes have been tested. This leaves significant portions of the software's logic untested, increasing the risk of undetected defects that could have serious consequences, especially in regulated industries. This failure to adequately test logical pathways constitutes a breach of the CMSQ duty to ensure software reliability and could lead to non-compliance with regulatory expectations for thorough testing. Focusing solely on path coverage without considering the practicalities of project timelines is also an incorrect approach. Path coverage, which tests every possible unique sequence of executable statements, is the most comprehensive but can be prohibitively complex and time-consuming, often leading to an unmanageable number of test cases. While theoretically ideal, its impracticality in many real-world scenarios means it is rarely mandated as a sole requirement. The CMSQ role is to select appropriate techniques, not to pursue the most complex method regardless of feasibility. This approach fails to demonstrate sound professional judgment in balancing thoroughness with efficiency. Ignoring white box testing techniques entirely in favor of black box testing is a fundamental error. Black box testing focuses on functionality without knowledge of the internal structure. While valuable, it cannot guarantee the thorough examination of internal logic and decision points that white box techniques provide. In a regulated context, relying solely on black box testing would likely be viewed as inadequate by auditors, as it does not demonstrate an understanding or testing of the underlying code's behavior, which is essential for identifying subtle defects and ensuring robustness. This represents a significant failure to meet the expected standards of software quality assurance in a regulated environment. Professional reasoning. Professionals in software quality management must adopt a risk-based approach to testing. This involves understanding the criticality of different software components and the potential impact of defects. When faced with conflicting priorities, the CMSQ should 1. Clearly articulate the risks associated with insufficient testing, referencing relevant regulatory expectations. 2. Propose a tiered testing strategy, prioritizing higher levels of coverage, like branch coverage, for critical modules. 3. Document all testing decisions and justifications, maintaining a clear audit trail. 4. Engage in open communication with stakeholders, including the project manager, to educate them on the importance of robust testing for compliance and product integrity. The goal is to find a balance that mitigates risk effectively without unnecessarily hindering progress.